All right, everyone. So, Algebra 2. So we're going to start 5.4 today, which goes over factoring. We've already done part of this assignment. Well, not really part of the assignment. We've already covered some of this topic already. This is going to be your homework assignment right here. There we go, 5.4a. Finish the selected problems from the worksheet. You'll get these worksheet problems in class. It looks like this. I also post this online so you guys have access to them. It'll be this assignment. That's what you guys will do for the homework or for the book assignment. Let's do warm up. You guys are going to turn this in the next time we have class. So let's see, today is Monday. You guys will get this tomorrow. So you guys will turn this in to me on Wednesday or Thursday, depending upon when I see you next. Okay. You're just going to find the GCF of these various numbers. Let's talk about the GCF is. This might be new terminology for some of you. GCF stands for greatest common factor, which might be not a new concept for some of you. So the greatest common factor. So for example, if I have the numbers, I'll pick a simple example. Let's do like 10 and 4. So I want to know the GCF of 10 and 4. The largest number that divides both of these numbers is going to be 2. There's lots of numbers that divide them individually. For example, 10 divides 10, 5 divides 10, 2 divides 10. 4 is divisible by 4, by 2, and then by 1. 1 also divides 10, sort of thing. The biggest number that is common to both lists is 2. So the GCF of 10 and 4 will be equal to 2. So I want you guys to find the GCF for these two values. That'll be your warm-up. Okay? Once you guys are done with that, go on and go to the next page. Alright, so this first one here, we've actually already done this part here, this first part here, this concept of backwards distribution. This concept of backwards distribution is really the same thing as the dividing by a monomial that we did when we were doing division of polynomials. So this is really just dividing by a monomial. Dividing by a monomial. Okay, that's really all this is, and we've done that already. So I'm not going to spend a lot of time on this. So like if we look at this example here, a factor that goes into both of these, the biggest number that you can take out of 15 and 24 is going to be 3. The largest power of x that we can pull out is just x, because there's an x squared here, but there's only an x here, so the largest thing I can pull out is x. That gives me a factor, a greatest common factor for these two values of 3x. We redistribute it back through, and we end up right back where we started. Okay, so that's reverse distribution. I'm not going to waste a lot of time on that. We already know how to do that. I'll let you guys do this practice problem on your own. The largest common factor of here is going to be 8x. So if 8x is the greatest common factor of these two numbers, what can we pull out? I'll let you guys sort that one out on your own. If you guys need help with this one, let me know in class. Okay. Okay, greatest common factor practicing. I will let you guys practice these. If you guys need the answers for these, please let me know. Actually, I can give you guys a couple of them here. So this first one here, the greatest common factor will be 3x squared. For this one here, the greatest common factor will be 6xy, it looks like. 6xy, yep. Yep, 6xy. And then for this last one here, the greatest common factor will be 2a and b, 2ab. So those will be your answers for that. Give it a try, see if you guys get the same answers that I do. We'll go to the next page. All right. For Miss Carp, when she first wrote these sort of things, she had a little lesson or a little game that she played here. So I'm not going to do this, but I like the idea here. So what's my number? In reality, I'm never going to put a clock on you guys to answer questions like these. But these questions that you see here, these are the kind of things you will have to answer for this next part that we're going to do. So we're looking for a number that two numbers that when multiplied will give you 24 but add up to 10. So if you guys can think really quick here, are there numbers that when we add them together will give us 10, but when we multiply them give us 24? The answer is 6 and 4. 6 plus 4 gives us 10. And 6 times 4 gives us 24. You can try the other ones here. We have negative 30, but add up to 7. I'll let you guys figure that one out. Negative 21, negative 4, another one for you guys to sort out. Let's talk about where and why we would actually need this skill. Okay, so we'll go to the next page. So when we need this skill is when we are factoring trinomials. So this trinomial here, this actually has a special name. We call this it's 3 terms. This has a special name. It's called a quadratic. This is the result of FOIL. Okay, so when we FOIL, we end up with something of this form, ax squared plus bx plus c. Okay, so that's when we have like x plus a times x plus b. We FOIL that together, we get something that looks like this. And then we're looking for the values that, or the two original values. So let me try that again. We want to factor this so that it looks like this again. Okay, so we will start with the trinomial and we want to end up with our true factors. This is specifically when a is equal to 1. When a is not equal to 1, we use a similar process, but there's an extra step to it. And we'll talk about that when we get to it. So the device we're going to use that we're going to use in class for solving these problems is something called the X-Man. Okay, so this is called the X-Man. Okay, and it's really simple. You're going to draw an X. This top number here is going to be the product of a. So a is the lead coefficient. So you have your x squared term, and you have a number in front of that. So we take that value multiplied by c. So this top number will be the product of a, let's try that lowercase, a and c. I'm kind of doing general terms here. For now, we're assuming a is equal to 1. So in general, this top number is just going to be whatever c is equal to. When we do terms, when we have a is not equal to 1, you will multiply a and c together to get this top number. So I'll go and introduce that concept to you now. Okay, and the bottom number is always going to be whatever b is. So this number here will always be whatever b is, where b is the coefficient on the middle term. Okay, so for the example that we have here, we're looking for two numbers that add up to 20. I'm sorry, that multiply together to give us 24, but add up to 10. You see that here? We have a 1 right here, so we take 1 times 24 to get this number. 10 goes here in the bottom, and we're looking for the values. They go on either side. Let me make sure I don't jump ahead. Yeah, okay, we'll go ahead and finish this example here. So I went over the answer a minute ago. It's 4 and 6. Okay, add together to give 10, multiply together to give us 24. So when you do that, you're going to expand it. This is ultimately what the X-Man is. It's just an organizational tool, but the method that we're doing here is something called expanding the middle term. So let me finish this example, and I'll show you where all of this comes from. So if we're going to rewrite the middle term using these two numbers, so we're going to get x squared. Scoot this up so you can see it. So we're going to get x squared. We're going to replace the 10x with 4x plus 6x. So we rewrite the middle term as 4x plus 6x, and then we're going to throw back in whatever our constant value is, which in this case is plus 24. So we have taken the middle term and we have expanded it. Now comes the cool magic step. So we're going to do something now that is called factoring by grouping. Okay, factoring by grouping. And the way that this works, let me focus this really quick. Okay, the way that this works is, let me grab another color here. Alright, so the way that this works is we are going to draw in parentheses around our first two terms and around our second two terms. There's a detail here that's not normally covered in books, and that is this value in the middle between the two sets of parentheses we have here. This must always be a plus. If you ever end up with two negative terms here, which you will see as I'm sure you'll see it on the homework worksheet, and you should see it in the examples here. If we ever have a situation where we have a negative here, always make sure that there's a plus here. So you have to do a little bit of factoring and manipulation in order to make sure there's a plus there. Just remember that always must be a plus here. Now what we're going to do is we're going to factor the individual sets of parentheses. So we're going to find the greatest common factor for each set. So the greatest common factor of x squared and 4x is x. So I'm going to pull an x out of each term here. So that'll give us x. X squared, when we pull an x out, is just x. And then the 4x, pull an x out, is just equal to 4. So we have x times x plus 4. We redistribute through, we end up with this term. Okay. Now we're going to do the same thing here. The largest or the greatest common factor that we can pull out of both of these is 6. So we're going to pull out the 6. 6x divided by 6 is x, and 24 divided by 6 is 4. Okay, now comes the magic step. There's a distributional rule that's actually happening here. You will notice that what we have here, we have an x plus 4 at this step and an x plus 4 at this part. Okay? Since we have an x plus 4 in both terms, we can factor that out. We can factor out an x plus 4. If you're not seeing that, another way to think of this is I'm going to say z is equal to x plus 4. Okay? And I'm going to rewrite this step right here. Okay? So this would really be the same thing as x times z plus 6 times z. Now the common factor in both of these terms is z. So I can factor z out of both parts, and I will be left with x plus 6. Okay, but this is not the final answer. We don't want z, so we're going to take this fact and we're going to plug it back in here. Okay, and we will end up with a final answer of x plus 4 times x plus 6. Okay, and these are is our factored version of this original trinomial. Okay, if we FOIL this thing back out, this is where all of this magic comes from. If we FOIL this back out, we will end up with x squared plus 6x plus 4x plus 24. So x times x gives us x squared. X times 6 gives us the 6x. 4 times x gives us 4x. You can't see anything that I'm writing. And then 4 times 6 gives us 24. Okay, so that leads us to this expansion. You'll notice here's our 6x and our 4x. The idea behind using the x-man is how do I backtrack my steps up so that I end up with this 6x and the 4x. I need to look at factors that give me 24 but add up to that middle term of 10. So factors of this number that add up to this number. And that's kind of the trick to doing factoring. Let's do a few of the examples here on the next page. We'll come back to that if we need to. So I'm not going to do all of these. I want you guys to have an opportunity to solve each of these. So I'll let you guys try them. I don't have the answers worked out here immediately. I'll try to write them down if I can figure them out really quickly. Let's go ahead and do number 1 here. We're going to start off by doing our x-man. Okay, so we're looking for factors of 12 that add up to 7. So you need to think through your factors of 12. What are our factors of 12? We've got 1 and 12, we have 2 and 6, and we have 3 and 4. Now think which of those pairs, when we add them together, give us 7. The answer is 3 and 4. So we'll put a 3 here and a 4 here. We'll go ahead and expand the middle term. So we'll get x squared plus 3x plus 4x plus 12. Okay, and then we can do our factoring by grouping. Okay. Common factor here is going to be the x, so I can pull an x out. That leaves me with x plus 3. Common factor here is going to be 4, so I can pull out a 4. Note there's a plus in between the parentheses. Pull out the 4. What I'm left with is going to be x plus 3. Notice these two terms are the same, so I can factor that term out. So I'm going to have x plus, well, let's do it this way. So I'm going to be able to factor out x plus 3. What I am left with is an x plus 4, which will make up my other term. And you can confirm that that is the answer by FOILing it out. Okay? I'm going to let you guys do the next ones. I will give you the answers though, but I want you guys to go through the x-man and doing the factoring by grouping to expand the middle term, or I'm sorry, x-man, and then I want you guys to expand the middle term and then factor by grouping from there. Just a second. All right, let me give you guys the answers for this, and then we will move on. Okay, so the answers for these should be, this one here should be, let me think, this should be x minus 1 and x minus 7. Okay, this one here, when you do it, should come out to x plus 3 and x minus 1. And this one should be x minus 3 and x plus 2 when you do it. So I'll let you guys try those out really quick, and when we come back, we'll move on to the next page. All right, everyone, so let's go back to where we were. So here's the problems that we just finished, the examples. Here's the answers if you guys need to check your work. If we go to the next page, we have kind of the problems that we were doing when we were doing long division. Now you can use synthetic division here. We have x squared minus 6x plus 8. You can set up synthetic division and find our factors that way. That goes pretty quickly. This is actually interesting because what they're doing here is they're giving us part of the puzzle. in general, it'll always work out to two things if you know it's factorable. You don't. There's really only one way to figure out if it's factorable though, and that is when you're using the X-man. We're going to plug in our values, so we're going to have 8 and -6. Okay. We're looking for values that add up to 8. I'm sorry, that multiply to 8 but add up to -6, and we are told that x minus 2 is going to be a factor. That's the factor we want to work with. Okay, so what we're going to do is we're going to take one of those numbers. You're going to notice an interesting relationship here. Let me see if I can grab one here. Let's look at number 1 on our last one here. So we had 12 and 7, so this is the x squared plus 7x plus 12. And we had 3 and 4 as our values. You'll notice here that 3 and 4 are the numbers on the other ends of the binomials that we got when we factored. So here we have -2. So I'm going to make -2 one of the values here. What we're looking for is whether or not another number can be placed here. So is there another number that we can put over here that will give us this value? Okay, so we're going to rack our minds. So we have 8. Let's look for factors of 8. We have 1 and 8. We have 2 and 4. But we're looking for numbers that add up to give us -6. We know that a negative times a negative is equal to a positive, so we're going to put -4 here. If you are not able to fill in the rest of the X-man, in general, it's not going to be factorable. This will not be a factorable polynomial. So you need to be able to fill in the whole X-man, or there's not going to be a solution available to you. This little trick, in general, it only works when we know that the trinomial is factorable to begin with. There's reasons behind that, but don't worry about that just yet. Actually, let's scratch that out for now. Just ignore that part. Okay, you need to be able to fill in the X-man, or you're not going to be able to factor it out. So we take whatever this value is, plug it in for part of our answers when we're finding our two numbers, and then you need to find the other number. And if you're able to find it, then you're able to sort out the division. I did this by synthetic division as well, so you have a couple of options there. Let's try some examples here. So synthetic division, this one here, if you're setting up your X-man, we're going to have 9 and -6, and we're told that one of the factors must be -3. So we're looking for factors of 9 that add up to -6. The other number is going to be -3. That lets us complete our X-man, and then we can move forward with factoring, or we can use synthetic division. Let's look at the second one here. This is the answer for this one, by the way, if you want to figure out, if you want to try factoring this one out. Same thing here. We're going to have -10 up top and -3 on the bottom, and we're told that +2 is going to be one of the values. So we're looking for factors of -10 that add up to -3, and one of the factors must be 2. The other one is going to be -5. Okay, so we get -5, 2 plus -5 is -3, 2 times -5 is 10. So we're able to find factors that way. Here's the final answer if you guys would like to work it out. Okay, we're going to move on to our next example here. I actually made a mistake the first time I did this, so we're going to do this on blank paper. So our next example that we have in here is, if you guys go to the next page, is 5x squared minus 13x plus 6. Now this is the case where a does not equal 1. So we have our, the form of our trinomial is ax squared plus bx plus c. Now last time when we were doing our X-man, we just put c in the top here. Now what we're going to start doing, and you can do this in general, this top part is really going to be a times c. So it's going to be the lead coefficient times the constant, and the bottom part of the X-man will always be whatever the middle term coefficient is. So for this particular case, we are going to have 5 times 6 goes in the top. 5 times 6 is 30. And then we'll have -13 in the top. So in order to find our two values here on the side, we are going to be looking for factors of 30 that add up to -13. So here's how I do this. The way I do this is I'm going to take 30 and I'm going to make a list of all the possible factors. So I have 1 and 30, 2 and 15, 5 and 6, and what else do I have here? 3 and 10. Okay, are there any others? I don't see any others, so that we'll run with those. And if I mess it up, I'll go back and fix this later. So we're going to try adding or subtracting terms together and see if we can get -13. So 1 plus 30 is 31, but 1 minus 30 is -29. Neither of those are really close to -13, so that's not going to work. 2 plus 15 is 17. 2 minus 15 is -13. So let's play with that for a second here. So we know that 2 and -15, okay, that will give us -13. That's a good sign. But if I multiply these together, 2 times -15, that's hold on, let's add it together. If I do 2 times -15, that'll give me negative 30. I want a positive 30. Okay, so this one actually isn't going to work. So this one didn't work. 2 and 15 is not going to work because there's not a product here. We get a sum that's equal to negative 13, but the product is not equal to 30. So that one's not going to work. 5 and 6. 5 plus 6 is 11. 5 minus 6 is negative 1. So those are the only differences that we can work with. So this one's not going to work. The next one we'll try is 3 and 10. If this one doesn't work, then this probably isn't going to be factorable. So 3 plus 10 is negative 13. 3 minus 10 is negative 7. But I want a negative 13. If I make both of these negative, though, that would be negative 3 plus negative 10. That gives me a negative 13. Yeah, negative 13. There's a negative 13 here. Negative 13. Okay, so that gives me negative 13. And negative 3 times negative 10. Negative times a negative is a positive. So that gives me 30. So that one works. So this one is going to be negative 3 and negative 10. So now that we've completed our X-man, okay, we're going to expand the middle term like we did in the earlier example. So we will have 5x squared. We'll do minus 3x, and then minus 10x, okay, and then plus 6. Okay, you might remember earlier when we were doing this before, I told you that the middle term, when we add our parentheses, always has to be positive. So what we're going to do is we're going to put parentheses around these two. I need this to be positive here, so I actually need to keep this negative attached to the 10, and then we're going to add a plus in between. So when you rewrite this, you'll get 5x squared minus 3x plus, always have the plus in between. So 5x squared plus 3x plus negative 10x plus 6. Okay, so that's our rewrite form. Always remember to keep a plus in between the two parentheses. Okay, all right, now we'll try factoring it. We'll see what happens. So the greatest common factor for the first two terms is going to be x. That leaves me with 5x minus 3. The greatest common factor for these two terms is going to be, I can pull a 2 out of everything. Yeah, that looks like the biggest thing I can pull out. So if I pull a 2 out of everything, that's going to leave me with a negative 5x plus 3. Well, that's not the same thing as what I've got over here. But if I pull a negative 2 out, then this becomes a 5x minus 3. So I will end up with x times 5x minus 3 minus 2 times 5x minus 3. Now I do have the same term in both sections. Okay, and I can factor out the common term, and I will be left with 5x minus 3. Once that's out, all I'm left with is the x and the minus 2, which gives me my other term, x minus 2. You guys can FOIL that back out and see that it's equal to our original trinomial. Okay, and that's factoring when a is not equal to 1. Okay, you'll see some more examples of this. I'm going to go through these kind of quickly at this point here. These ones take a little bit more time. We'll do the second example, and then I'll let you guys play with the examples that are here on the last page on your own time. These ones I don't have the answers for. I can figure them out. I'll show them to you in class if you have questions. Let's do this one really quick here. So we'll start off with our X-man. So negative 3 times 8 is going to be negative 24. Okay, and we put a negative 10 in the bottom. I need factors of negative 24 that add up to negative 10. So negative 24, let's make a list of all the factors we can think of. We have 1 and negative 24. You can do an exhaustive list of this if you want to. So since this is negative, that means one of the factors has to be negative. So I can do minus 1 and 24. I can do 2 and negative 12, or negative 2 and positive 12. I can do, let's see here, let's do 3 and negative 8, or negative 3 and positive 8. 4, I can do 4 and negative 6, or negative 4 and positive 6. Let's see if I can do anything else. 5 doesn't work. When I get to 6, I'm actually starting the list over when I get to 6, and I start going the other way down the path. So we've got all of our possibilities here. So these are all of our factors of negative 24. Now we need to figure out values that add up to negative 10. So this one is equal to negative 23. That's not going to work. This one is equal to 23. That's not going to work. This one is equal to negative 10. Ooh, Hey, that's what we're looking for. Let's see if there's anything else here. Really quickly here, just well, we've got this. This is equal to 10. That doesn't work. This one's equal to -5. That doesn't work. This one's equal to +5. That doesn't work. This one will be equal to -2. And this one, +2. So the only one that works is this one, 2 and -12. So let's throw in those two factors. Okay, one of these is negative, so we can avoid that situation we had in this last one where we had to add in the plus just by changing the order of our factors when we rewrite the middle term. So when we rewrite this, we're going to get -3x squared. And let's put the negative one first. That way we don't have to deal with the parenthesis change. So we'll have -12x plus 2x, and then we have the constant, which is 8, so plus 8. And now we'll do our factoring by grouping. Notice that by putting the -12 first, we didn't have to do the thing with the negative and do that rewrite part. So now we'll do our factoring by grouping. Out of these two terms, I can pull out a -3x, which will leave me with an x plus 4. You can redistribute that if you want to make sure that that's correct. Here, we can pull out a 2. So we're going to pull out a 2, and that will leave us with an x plus 4. Always make sure that these two terms are equal. If they're not equal, there's something wrong. You need to go back and check your factors again. Okay, so we're going to pull out the x plus 4, and what we're left with is the -3x and the 2, which gives us our other factor. And if you FOIL it back out, you'll end up with our original trinomial when you FOIL it. Okay, there we go. I'm going to leave these last two for you guys to do on your own. If you have questions on these, we'll do them in class. I know the video is running a little bit long, so I want to make sure I finish this up here. Remember that you guys owe me a warm-up. I'm going to add a little extra piece to it here. If you guys will write at the top of it, write aluminum foil. Write aluminum foil on the top of your warm-up when you turn it into me, and I will give you guys an extra credit point, making the total extra credit available on this 2 points. Whoa. Okay, so remember, aluminum foil goes at the top of your warm-up. Okay, I'll see you guys in class.